All right, ladies and gentlemen, we got some interesting problems going on today. Some interesting problems, all right? And I just want to make sure that we are going to be able to do these problems right. So, just want to go ahead and... Uh-oh. Now you see it. Now you see why I called it interesting problems here. We got ourselves some simple and compound interest questions that we're going to be looking at today. Interesting. You get what I'm saying? Look, here's the deal. There are two types of interest problems. I mean, you can see it at the very top. Let me go ahead and give you a highlight. We got simple interest, and then we got compound interest, okay? We got two different types of problems. Now, there's some formulas we're going to have to understand, all right? The most basic formula is the I equals PRT formula, okay? The PRT formula. The R represents the interest rate. Usually as a decimal, okay? Usually as a decimal. The T represents the amount of years that this interest is taking place, okay? The P stands for the principal. That means what you started out in your bank account with. And of course, the I stands for how much interest you've accrued over that time. How much interest you've earned. Or maybe how much interest you've accumulated because you have to pay back a loan, all right? So we got another formula. This is a formula for compound interest, and actually I'm going to write the universal one. Usually the ones that they show you on the formula charts have the compounded annually formula, but I'm going to show you the universal one. It's A equals P parentheses, all right? P again being the principal, the number 1, which represents 100%, okay? That's why we're putting the number 1, plus R divided by N. R being the interest rate again, the N meaning how many times within a year this interest is going to be compounded, okay? And then that's going to be raised to the R times T power, all right? So usually that's the formula here. You know what? I'm not going to lie to you, man. I actually messed up. It's not raised to the R times T power. It's raised to the N times T power. And we'll see what I mean right now. So I laid a little boo-boo. Mr. Delgado making boo-boos here. It happens, man. It is what it is. You know, I'm not the best. Sometimes I forget my formulas. I don't know why I put an R. But it's really raised to the N times T power, okay? And we're going to see this in action, okay? Look, you know what? There's another little formula that we got for simple. And we might be able to see it in a little bit. Actually, we're going to see it right now, probably not. So first things first, we got ourselves Dr. Lillian. She's putting some of that money in the bank, 5 years. Okay, so we got our principal already. We got our time. And we got our rate right here, rate. Okay, so the first thing we got to do is make sure we're using the right formula. Now, how do we know we're using a simple formula? Because it's a simple interest right there. I'm going to tell you something. Here's what's interesting when we do this problem, all right? That's what's interesting. So first things first, my P, 7,500. The interest rate is going to be 4.25%, but we don't want it as a percent. We want to change that thing to a decimal. So we're going to go ahead and change it to 0.0425, all right? Next is going to be our time. Our time is going to be 5 years, all right? 5 years. So now we can go ahead and do this problem. We use our interest formula, which is P times R times T, and it's pretty easy. 7,500 multiplied by 0.0425. That's a 4, sorry about that, 4, and then we're going to multiply that by 5. So hopefully you got your calculators ready, because I got mine right here. We're going to go ahead and set this bad boy up. All right, so 7,500, we're going to hit enter. 0.0425, we're going to hit multiply, and then 5 multiply, simple as that. So, well, first things first, what we solve for is not the amount in the account. What we solve for is the interest. That's what the I stands for, the interest. So you should be hitting yellow show because of the money problem. But I got $1,593.75 in the account from interest. But that's not just what's in the account. When you put the money in the account, the money has your original money in the account, the principal also. So what we got to do after we got that is add our original principal, which is 7,500. We go ahead and add it, yellow show, and now we got ourselves an opportunity to put on our correct answer here. So now it seems like my answer seems to be 9,000 and $93.75. Okay, so for our accumulation, our accrued amount be A, the total amount in the account, well, we had to add the principal back. And if we're adding the principal at the end, we could actually derive ourselves a new formula for simple interest. Notice how really the accumulation for simple interest, for the simple, is actually PRT plus another P at the end, the original principal. Now, if we take a look at this right here, we could even come up with a factored form. Notice how I'm using the word factored here, because we could factor out a P from both of these. We have PRT as a term, and we got P as another term. So really our formula, it's going to end up looking pretty interesting, especially since we got this other formula over here we could take a look at right here. This formula right here, it's going to look very similar. So the simple interest formula actually becomes P parentheses 1 plus R to the T. Okay, now I know it's kind of hard to read there. Let me go ahead and write it over here. But if you really want to get really good with this, and you want to come up with your formulas that do this stuff really quick, to find the total amount in the account of simple interest, it's P times R plus T plus the number 1. That's our derived formula for finding the total amount in the account. Okay, so I mean, you could do that, or at the end of the problem, you could just go ahead and add the principal back to it. But there you go. That's what it is. All right, let's take a look at number 25, the next one. Okay, we got ourselves a $450 in the savings account. Okay, we starting off good. We got ourselves the 4.75% simple interest. Notice the simple, we're going to be using that simple formula, at least one of those. Calculate the amount of interest earned in 10 years. We got our time, 10 years. All right. Yeah, if you don't see it, I mean, I'm underlining it again for you. I'm highlighting again. So my P in this problem, well, we can't use that. We got to use something else here. Let's go ahead and use my purple pen. We got our principal here is 450. The rate for this is going to go ahead and be 0.0475. Notice we got to change that percent into a decimal, okay? I mean, you could also divide it by 100, 4.75, enter 100, divide. That's how we change it. Or we can move the decimal 2 times to the left. Whatever works best for you. So we got our time also in this problem, and it's going to be 10 years. So for this, we don't have to find the total amount in the account. We're only looking for the interest earned. So in this problem here, our interest earned will be $450, how much we started with. Our interest rate of 0.0475, and then we're going to multiply that by 10. So here we go. Let's see what happens. All right, so we got $450, enter. We got 0.0475. We can multiply that, and then we just get our next 10 and multiply. Remember, there's a money problem. You want to hit yellow show, and there we go. I got $213.75. Hopefully you got the same thing, and we're on our way to success. And I want you to notice something. I really like these type of problems. Why? Because you get to see that you could get money working for you. You don't always have to work your whole life. You could start investing some of your money, putting it into an account that gives you interest, and you can start saying over time, man, over time we could get some of that money back. And not only will we get money back from it, you'll have the original money you put in there. One of the wonders of the world, interest. All right, let's take a look at our next problem right here. We got ourselves Donna, again putting $450 in the savings account. The interest rate again is 4.75%. Wait a second, we see compounded annually. So here's the beautiful thing about this problem. It's compounded annually. We're going to have a different type of problem. Now check this out. We want to figure out only the interest earned in 10 years, okay? We only want to figure out that. So again, we got to make sure we got the right formula. So we got A equals P parentheses 1 plus R over N raised to the N times T power. Okay, now here's the deal. On your formula charts, 8th grade formula chart for state of Texas, we actually see this formula because this is the compounded formula automatically for compounded yearly, okay? Why? Because our n in this problem is going to be equal to 1. Because it's only compounded once in a year. So the rate divided by 1 gives us the rate. Like this is essentially, this right here is going to be the same as this. And then 1 times our t, the number of years, well, it's going to give us t. Because we're only compounding this annually, 1 time a year. So if you really get good with your memorization, if you really get good with deriving formulas, you know, you could use the second formula automatically. But I want you to notice something here. The second formula doesn't solve for interest. It only solves for the accrued amount, the total accumulated amount in the account. So let's go ahead and get this started. So our total amount in the account is going to equal to the $450 she starts off with. But then we got to go ahead and put the parentheses 1 plus. I'm going to go ahead and use this formula right here because we don't need to divide by 1. We don't need to multiply our power by 1. We don't need to do that. But, you know, I want to go ahead and expose you to that formula. So we're going to go ahead and now add 0.0475, and then we're going to raise that to the 10th power, okay? But I hope you remember, this formula doesn't give us the interest. So we're going to start with 450, enter. We're going to go ahead and hit 1, enter again, 0.0475. We're going to add it. And now we're going to go ahead and get 10, raise it to the 10th power, and hit multiply at the end. All right, so here's the deal. We end up with about $715.73 or 74 cents. Depends on how you want to round this. So I would think we would just write that in. But then again, I'm not thinking very well because what we solve for is the total amount in the account, and they ain't asking for that. They're only asking for the interest right here, the interest earned. So there's one more thing we got to do. Remember that last problem where we had to add, you know, that very first problem we did, we had to add our original principal to figure out the total amount in the account? Well, since we already have the total amount in the account, we got to do one more step. We're going to get the original principal and subtract it. We're going to subtract it so we could kind of see how much of this money was interest that we earned from our money in the account. So let's go ahead and subtract the initial $450, our principal, hit yellow show, and notice what happened here. We got $265, and I'm going to go ahead and round it to 74 cents because, you know, we always round up when it's 5 or up, but you could have put 73 cents. Notice this is why they give you that 1 cent error, because it just depends on your rounding, depends on what you want to end up doing here, okay? So in this problem, we could see if you have a choice between simple or compound interest, I mean, geez, I mean, the choice is clear. Always select compound because, I mean, you just get more money. And, you know, if you don't know what simple and compound interest really is, I mean, there's a lot of good videos on YouTube where you could go ahead and ask me and I'll explain it to you because this is my bread and butter. I love this kind of stuff. But we got to make sure we know how to do this. Now, maybe you might even be able to derive your own formula for how to figure out the interest of, you know, compounded problems. And it's actually pretty easy. We have P, and then we're going to go ahead and do the same thing. 1 plus. I'm going to go ahead and use the compounded n times a year formula. You know, n to the t. But at the end of the problem, if you just want the interest, we have to subtract our initial principal. Okay? And that's how we figure out the interest earned in this account. Okay? So it's a lot of stuff. It seems pretty intense, but the more we practice, it gets a piece of cake. Okay, so let's see what we got. Calculate the percent interest. Oh, we're going to look for the interest, the percentage. No, it's a percentage, right? On 1,200 needed to match the interest earned on $500 at 5% in 1 year. Okay, so this one looks like a good problem here. Because in all honesty, they're asking us to work forwards to figure out the interest of an account. Right here, $500, we're going to go ahead and multiply that by 0.05, and then we're going to multiply that by 1, which we don't really need to do. So in this problem right here, we're going to go ahead and do this. 0.05, 500 multiply, and guess what we made in this account in 1 year? Well, as you can see here, we made, what is this? $25. $25, not bad, not bad. $500 in the bank, you end up with $525 at the end of the year. Not bad. Make the money work for you. But now we got to check out, well, if I want to figure out what my percent interest has to be on 1200, but now I got to work this out backwards. We're going to still use that I equals PRT formula, but notice our interest here is already solved for us. We already know we want $25. Well, really, we want more than that. We want to get as much as we can. But in this problem, we needed to match it, at least match it. My principal is going to be 1,200. We already know the R is what we're looking for, and then we could put the 1 year for the time, but technically we don't need to. So in this problem here, we're working backwards. What we really got to do is divide both sides by 1,200. All right. Guess what happens to the 1,200? I mean, I think you already know. Guess what? They cancel out. We're left with 25 divided by 1,200 is now equal to the interest rate. Now notice something here. They don't want this. They do not want this in a decimal, but we're going to end up with the decimal answer. So 25, then we're going to get 1,200 divide, and we get a decimal answer. But notice they want a percent answer. And how do we change a decimal into a percent? Well, we're going to have to get our answer and just multiply it by 100, okay? We multiply it by 100, and now we figured out that our percent rate has to be 2.08. Or if you want to write in scientific notation, 2.08 times 10 to the 0. Notice, this is the first problem we've done where we could write in scientific notation. The other problems, we couldn't. Because once we see that dollar sign means you better write all the dollars, you better write those 2 cents decimal spaces. Okay, we better do that. But for this one, since it's not an integer problem, it doesn't have a dollar sign in the front, as you can see, there's nothing here, nothing here. We just go ahead and do the problem, write it either form right here or right here. Either form, and we're good to go. We're good. We got it. All right, let's check out this next problem right here. Whoa, ho, ho, ho. So we got ourselves another interest. We got ourselves, look, I like these problems. They're super interesting. We invested $7,250. So that's already telling me right here we know our principal. And we've already earned $923.39. So that's in simple interest over 2 years. I love that it's as simple. We already know we're going to use one of these formulas. Calculate the interest rate. Yet again, we're not working forwards, we're working backwards. We got I equals PRT. We're going to go ahead and start substituting. 923.39 equals 7,250. Now, we're looking for the interest rate. And notice, it's in percent form. So we're going to have to multiply by 100 at the end to turn it into a percent. But we actually already know how much our time is. It's different than 1. It's actually 2 years. So in this problem, what we could already do, notice what I'm going to do. I'm going to do it right here. We could already start simplifying. We could go ahead and do 923.39. We could start eliminating things by dividing both sides by 7,250. So we could cancel this bad boy out. But once we divide both sides by that, we still need to divide both sides by 2. So really, our formula ends up being this. We got 923.39, $923.39. We're going to go ahead and get 7,250, which is our initial principal, multiply it by 2, and then we divide it from our interest rate earned in the account for 2 years. And guess what? We got ourselves our answer here. So, you know, it is what it is. We write 6.37 times 10 to the negative second, and we're done. No, we're not, because this is a percent problem. You better have answered it. You better have caught it before I wrote it down. We still got to multiply by 100 because we're changing this into a percent. And now we're good to go. We got 6.37 or 6.37 times 10 to the 0. Remember, we got to think reasonable here. Reasonableness. And most of the time, like 95% of the time, our percentages need to be at least some sort of whole number. At least some sort of whole number. It's not an integer problem. It's not a money. We don't see it here. We just see a percent symbol at the end, so we better write it in either standard form or scientific notation. All right, let's take a look at the next problem right here. All right, we got $5,000 being invested at 6% interest compounded quarterly. There you go. There you go. We're going to be using that other formula for 5 years. Calculate the amount of interest earned in those 5 years. All right, so before we start this problem, we got to write the correct formula. It's A equals P parentheses 1 plus R over N raised to the NT power. Now we're going to actually have an opportunity to substitute. This being the key word, quarterly, quarterly. Quarterly means we're going to compound 4 times. Think quarters, 4 quarters in a dollar, 4 quarters in a year. Well, if you talk about seasons here. In the business world, we talk about quarters, okay? First quarter, second quarter, third quarter, fourth quarter, okay? So we got to understand that, there's what we think quarters are, maybe, money, but there's also a lot of different interpretation. But at the end of the day, mathematically, a quarter is 1/4. So we're basically going to get this R and cut it into 4. So let me show you what I'm talking about. So my principal, my accumulated, my accrued amount. You know what? Maybe I could use that other formula. Well, I'm going to leave it alone. But maybe if you see it, you could already write the interest earned is equal to your principal 1 plus R over N raised to the N times T. And at the end, we just subtract. That's our interest. That's our interest for compound. That's what it is, okay? But, whatever works for you. So in this problem, we're substituting here. And I'm going to go ahead and, first off, I'm going to go ahead and select this and move it to the side. Because I might not have enough, I might not have enough space. So I'm going to grab this. I'm going to shift this bad boy right over here. Okay, because I might not have enough. Whoop. That didn't really work out too well. So you know what I'm going to do? I'm just going to go ahead and, go ahead and just do a little bit of this. Let's just undo a lot of that. Okay, yeah, maybe I won't need it. Any case, let's go ahead and check out what I got here. So we got ourselves what? You know what, before I go on any further, I don't like this little thing at the end. I want to see all white. So let me just scooch this a little bit. There you go. Hey, look at that. Look at those teeth. Look at those pearly whites. Yeah, boy. Okay, sorry about that. Any case, let's go ahead and do this. Let's do this right. So, my principal, I think I killed at least a minute there talking about this right here. Anyways, my principal is $5,000. We're going to have the number 1 plus my rate in this problem is 0.06 because we changed that into a decimal. We're going to divide it by 4. And then we're going to raise it to the 4 times 5 power. 4 because it's quarterly, compounded quarterly, and we got 5 years. That's what it is. So let's go ahead and check out our calculator here and let's do our problem. 5,000, boom. Then we're going to go ahead and get 1, enter, 0.06, enter, 4, divide. We should see 0.015 in our calculator right now. And then we're going to hit plus. So we got about 1.02. That's what our calculator is showing, but it's really 1.015. Okay. Now we're going to go ahead and hit 20, because I'm using that brain, using that math knowledge, and then that number sense skill, raise it to 20th power, and then multiply that by my initial 5,000, and we write this down. We sure don't. We got to get 5,000 and subtract, because we don't want the total amount in the account. We just want what's going to end up being our interest earned. And in this problem, we got 1734.28 cents. You might write 27, still count it correct, but since it's 27.5, it's 27 cents and a half. That's why I wrote 28 cents. Well, I usually try to round, okay? So let's get this next problem. Let's get it here. Let's get it, okay? So I got myself Jake. Jake deposits. Deposits basically means that he's putting money in the bank. And he earns 4 1/4%. But see, I got that math mind. Hopefully you got that math mind too. You could go ahead and immediately change your math mind into 4.25%. Compounded semi-annually. Okay, we're going to have to use this crazy formula again. If it keeps the money in the account for 10 years, calculate, there you go. Calculate the what? The interest? total, and we're going to use it for 10 years. So we're going to use that same formula. A equals P parentheses 1 plus R divided by N raised to the N times T power. And since we already want the total amount, we don't have to do anything except, well, substitute correctly. I was about to do it in my calculator, but I realized I didn't know what to substitute. Look, I'm going to tell you again. 4 1/4, you got to start thinking about it as 4.25%. And even better, it's 0.0425. Okay, it's 0.0425. But let's say you didn't know that. Let's say you didn't know that thing over here. You didn't know 4 1/4. So what you could have done in your calculator is hit 4.1.4. That's the 4 1/4, right? That mixed number. And then since it's a percent, you could go ahead and do 100 divide, and it automatically turns it into the correct decimal. I see it right now. 4.25 times 10 to the negative second. Remember, to change a percent into a decimal, divide by 100. Mathematically, that's what we do. If you want to change a decimal into a percent, you multiply by 100. That's what you mathematically do. Okay, we got to be able to use the math terms correctly, because we don't know when we might have to teach somebody else how to do this, and if you represent me, you better be talking correct. You know what I'm saying? I'm that math trainer here, and I'm training you to be the best. So let's be the best. All right? So we got our principal. It's 1,000. Let's gonna go ahead and multiply that by 1 plus my rate in this problem is 0.0425 over semi-annually. Annually cut into 2 pieces. So we're gonna divide it by 2. And then we're going to go ahead and raise it to the 2 times 10 power. Some of you could do this already. I mean, it's pretty easy. 1,000, enter it. 1, enter it. 0.0425, enter it. This is triple enter before we do any real work. 2 divide, immediately hit plus sign because it's in the parentheses. And then we're going to raise it to the 20th power, right? And then we're going to hit multiply. And then we got ourselves a great answer here, okay? Now, I'm going to do this one more time because I don't think I put everything correctly in my calculator. I mean, I didn't. Wait a second. Maybe it did change. Because maybe you might have noticed it didn't change. But my problem, I noticed it didn't change. But maybe it did change. 1 plus 0.0425. Enter. 2 divide plus. Raise it to the 20th power. And then hit multiply. It did change, my friends. It did change. It's the same number. 1.52. But instead of being raised to the 0 power, it's being raised to the 3rd power. You want to know why? Because we're getting that initial amount and we're multiplying it by 1,000, which basically means we're moving our decimal 3 times to the right. That's why it's going to be raised to the 3rd power. So again, you know, sometimes I freak out if I see the same number. I'm like, oh my God, I did it wrong. But if you think mathematically, it's completely reasonable about what happened. Hit that yellow show. We got 1,522. Remember, it's money. I underline it. It's money. So you better hit that yellow show. And then we're going to go ahead and put 79 cents. Of course, some of you want to put 80 cents. But then you'd actually be technically wrong because we don't round on this one. We don't round up. It's 794. So we don't round up. But you could be off 1 decimal. So that's okay. You could be off 1 penny. That's all right with me. Okay, as long as you get it right. As long as we understand these formulas. Oh, mommy and daddy, thank you a lot. Always thank your mommy and daddy, especially if they're helping you, okay? Make sure you help them out. When you get that big money because you go and invest your money early, take care of them for a while. Take them out to dinner, you know what I'm saying? Because, you know, mommy and daddy have probably helped you out a lot in your life. Well, we got $10,000 that they're putting in a compounded annually account for 5% when, you know, we got a little daughter going to college. That's cool. 18 years later. Ooh, that's already a time, 18 years. Calculate how much they will have in the account. How much they will have in the account. We're not looking for the interest. We're looking for the real stuff. The total accrued amount. So again, P parentheses 1 plus. And look, since it's only compounded annually, I ain't going to do any of this fancy divide by N and all this stuff. We're just going to do 1 plus R raised to the T power. So in this problem, I'm going to go ahead and substitute it correctly. Our total accrued amount is going to be equal to 10,000 times 1 plus my rate is going to be 0.05. Hopefully you just do that in your head, and we're going to raise it to the 18th power. And let's see, that $10,000 that mommy and daddy put away, Let's see how much it's gonna last. How much it's gonna give us in 18 years. Now look, I don't want to be saying this because, you know, sometimes this is what the banks give you, 5%. But really, legitimately speaking, in the stock market, I mean, historically, you get an average about 12%, you know? So, it wouldn't be that big of a thing. I mean, it would be pretty cool. It would be real cool, you know, start investing young. Because, man, I already see, wait a second, 1 plus R just turned into 2.41. Wow, that's when we hit multiply, bro, that $10,000 that they put away when you were born, dude, it just turned into $24,066.19. Whoa, I could have gotten that big time wrong. Big time wrong. Look at that. Look like a comma. You don't put commas. You put decimals. I could have got that big time wrong. So make sure you write legibly, okay? Because I almost messed up there. But man, it's just that I'm over here freaking out that, dude, $10,000 more than doubled. More than doubled. Imagine you do that every year. You start saving for your retirement. Maybe not $10,000 in the beginning, but you know, when you start getting your good professional job because you went to college, you're working hard, you start putting some of that money away every year. Dude, I mean, hey, money adds up, and you start putting some of that away. I mean, man, it'll start adding up for you, man. It'll add up for you. All right, so let's take a look at this next problem right here. We got $752, and we're repaid in a 7-month loan at 9% simple interest, okay? They already told us our total accrued amount. Now, of course, I would need to use this formula, okay? So we're borrowing $752. So, I mean, that's everything. That's the principal plus. Remember, we might have to use A equals, because it's simple interest, we're going to have to use 1 plus RT here, okay? Multiplied by the principal here. You know, we might have to do something like this, all right? We might have to actually work backwards from this to see what was borrowed if we had to pay a total of $752. Notice this problem is real crazy because we got a 7th-month loan. We've been talking about a lot of yearly terms here. 7-month loan. But that interest rate, well, that's pretty easy. It's 0.09. We don't got to worry about that. Let's start substituting. We got 752 equals to 1 plus. Now, I'm not going to write R because we know the rate. 0.09. Now, here's where it gets kind of fishy here. We're not going to put it times 1 times 7. You put times 7, you really lost. It's not 7 years. 7 months. How many months are in it? You know what? Maybe we're going to have to write a fraction. Maybe we're going to have to write 7 over 12. Because it's 12 months in 1 year and we're only borrowing for 7 months. And that, all of that multiplied by the principal is going to give us 752. So maybe for this problem, I hope you see we're going to work backwards here. We're going to get 752. We're going to divide it by 1 plus 0.09 times 7 over 12. And that's going to give us our original principal. How much we started this problem with. It's an intense problem right here. But don't freak out. I'm telling you, don't freak out. Many people freak out. They're like, oh, money. I can't handle the money. It's not hard. It's not hard. But we just got to understand what we're doing here. Man, I'm trying to add this 9, make it look like a 9. There you go. At least it kind of looks like a 9. 752, enter. 1, enter. 0.09, enter. Man, all these enters. 7, enter. 12, divide. There you go. Now we're starting to do that work. Then we could hit multiply. Then we could hit plus. And then we divide it from our 752. Wait a second. I think I did. Wait, yeah, nah, I'm just messing around. I think I got this. Divide. And it looks like we borrowed initially $714.48. Man, let me correct myself. 49 cents, because it's 48 cents and 9/10 of a cent. So it rounds to 49, okay? So there you go. We borrowed $714.49. probably buy something at the store. And then with the repayment and stuff, maybe some store gave us some, man, that store didn't give us a good interest rate like these banks. I mean, that's a kind of high interest rate, 9%. I mean, it's actually more than what they're giving us at a bank here. Maybe we're learning a little life lesson here. Maybe we're learning a life lesson. Maybe we should be not borrowing so much money here because they give us a little higher interest rates, That means we got to pay more. So there you go. I mean, I hope you noticed that one too. I want to throw that one out there. Don't borrow a lot of money. You borrow money, I mean, sometimes you end up having to pay back more money than it was really worth to borrow. You know what I'm saying? So it may not be worth it. Okay, let's take a look at this next problem here. Let's take a look at this next one here, okay? So we got ourselves $1,000. And we got this invested at 3 3/4%, okay? I hope you see that bad boy right there. We got $1,000. We invested 3 3/4, or 3.75. Hopefully you're thinking about it like that for 10 years. What is the positive difference? Ooh! Between the money being compounded annually, and compounded quarterly, Nah, but it's all good. We're just messing around, So let's go ahead and see what the positive difference is. It seems like we're going to have to do two different formulas here, but it's all good. We got our interest formula, my total amount accrued. We're going to go ahead and start with the annual one. We got 1,000. Why 1,000? Because, it's P, parentheses, 1 plus R times, right, it's R to the T, right? I mean, that's what it is. No, it's 1 plus R. Sorry about that. My mind's freaking out over here. I saw this one up here and over here, but this is the one for simple interest, okay? That's why we just multiply by T. This one we don't multiply by T. We raise it to the T power. That's why I'm over here freaking out. Anyways, I'm not going to put those. I'm actually going to put the actual numbers that I should be substituting. Now, this is 3.75%. So let's go ahead and write 0.0375. And then we're going to raise it to what? 10 years. Okay, that's our first formula we're going to do. This is the compounded annually right here. This is the annually formula here. Okay, but now we got to worry about the quarterly formula. This is the other one, the one that we're going to use that N. We're going to use that N. So it's going to be our total amount. And it's going to be 1,000 again. 1 plus, now our rate is 0.0375. And we're going to go ahead and divide that by quarterly. There you go. 4. Hopefully you went ahead and wrote this in. And then we're going to do 4 times 10. Or to the 40th power. We're going to get both of those. And then we're going to have to find the positive difference. Positive already telling us we don't want a negative answer. We're going to have a positive answer. That's what it's saying. We're going to find the difference. We're going to subtract. And then we're just going to find the answer. So 1,000. Then we're going to do 1 enter. 0.0375 plus. Raise it to the 10th, and then hit what? Multiply. We got our first answer. It should be roughly $1,445. Not bad, man, but that interest rate is real weak. 3 point number, dude. That's nothing. That's nothing. All right, but let's take a look at the next one here. That's just my personal opinion. And, well, my personal opinion might be based on some facts. Maybe you should check it out. That's the beautiful thing about math. You could always check for yourself. So we're doing the compounded quarterly form. We got 1,000. We got 1 enter, 0.0375 enter, 4 divided, because we're compounding it quarterly. That means 4 times in 1 year. Okay? And then after that, we're going to go ahead and add that to that 1. Then we're going to raise it to the 40th power, or 4 times 10 power, and then hit multiply. So in this problem here, we got 1452.45. All right. So let's see what we got. Wait a second. Ah, man, it didn't say the last one here. Okay, so let me go ahead and do something right quick. Let me go ahead and just figure this one out. 1.0275. Look, this is a perfect opportunity. Like, I just messed up. I typed 1,000 a couple times, and I forgot the last number that I put in there. So, this is a perfect opportunity for you guys to make sure you know how to store numbers, or at least write them down. I should have honestly written it down, because I'm over here talking to you guys, and I didn't see it. So I got 1,445 for my first answer. Where's that my second answer? I don't even know. Oh my God, I hit the wrong button. I hit overflow. Game over. I'm going to write these numbers down. I'm messing up. You don't hopefully mess up. Let me go ahead and just do this real quick. Okay, man, I'm messing up big time. I have no idea what's going on. 1,000. Then I got 1, enter, 0.0375 plus 10, raise it, multiply. Okay. Oh my God, I keep pressing wrong buttons here. 1,000, enter, 1, enter, 0.0375 plus 10, y to the x, multiply. So my first answer for the compounded annually, I'm gonna write this bad boy down because I'm gonna end up messing this up. 1445.04. Okay, just in case. I mean, honestly, look, it's pennies. It's pennies, and we're gonna end up subtracting. I think we could get a 1 penny difference, but if you want, maybe write that 3/10 after the 4, because you know we might mess up here. Next one, 1,000 again. 1, enter. 0.0375, enter. 4, divide, plus, raise it to the, man, it says 4. I keep hitting undo or something, man, because it should be 4 times 10, 4 to the 10th power, 40, y over x. And then we have multiplied that. So now I got for the compounded quarterly, man, dude, this one's actually taking some time here. Well, it's taking time because I'm over here trying to teach this, and obviously I ain't doing that good of a job, man. I'm over here kind of messing up, but now I got both of my numbers that we could use. So we gotta find the positive difference. 1452.45. We're gonna hit 1445.04, hit subtract, and apparently my difference is gonna be about $7.41. Look, I ain't gonna lie here. This looks like a state problem. This looks like a regional qualifier problem. This is one of the big boy problems. This is what separates the people who get in the top 10 and the top 3. This is that kind of problem. And I'm okay with it because I'm here to teach you guys. But man, that was an intense little problem right there. A lot of work. You got to know a lot of different formulas. But you know what? With me as your teacher, we're going to get there. We're going to get a lot of these formulas and we're going to show them what's up. And what do I mean by that? We're going to show everybody. So we got Daddy invested $20,000 for 6 years at 2.25%. I already converted in my head. That's not a good dad. I mean, he should got a better interest rate than that. I'll tell you that. But whatever, it works for him. If the interest rate is compounded quarterly, oh, that's cool. Calculate the balance in the account. That means the total amount, the accrued amount, the A, after those 6 years. So we're going to use compounded quarter. A equals $20,000. Not bad, not bad. That's cool, that's cool. 1 plus. Look, again, I'm already changing it. 0.0225. Compounded quarterly means we're going to divide it by 4. Okay, remember, that's a 2. And then we're going to raise it to the 4 times 6 power. Okay, so let's go ahead and do that problem. We got ourselves $20,000 to begin with. 1, enter. 0.0225, enter. 4, divide, plus. And then we're going to raise it to the 24th power because 4 times 6 is 24. If there's something I know, it's my multiplication tables, man. You got to do those right. Then we hit multiply. And guess what we got here? That didn't do that bad. I mean, with that low interest rate, I mean, he could do a lot better. But 22,000, remember, it's got to seem reasonable. Obviously, the total amount of the account's going to go up with this compounded stuff. So the answer's completely reasonable. And we have about 8 cents also at the end. It's 0.07, but since it's 0.8 of a cent, we round up. There you go. Next problem. Dan deposited $10,000 in the account for 2 years compounded quarterly, okay? So that's good. That's good, and we're compounding it quarterly, okay? At the end of those 10 years, he had 1,000. Oh, he had 11,000. Wait a second. This one looks like we're going to be working backwards here. We're going to be working backwards here. This is interesting. So let's go ahead and see what we got here. All right. So we got 11,000 as our accrued amount. Our principal is 10,000. Then we got that 1 plus, this is our interest rate, which is R, divided by 4, raised to the 4 times 2 power. Or even better, I'm just going to undo that. Let's just go ahead and put the real 8. But hopefully you see where that 8 comes from. I'm going to tell you one more time. That 8 comes from 4 times 2, okay? Man, we got to undo all of this. Well, let's do it. First step. We're going to divide by 10,000. So let's do it. I'm going to do it on my calculator. Hopefully you're following along. We're going to get 11,000. We're going to divide it by 10,000. And now we got 1.10 times 10 to the 0 power, or 1.1, all right? So that's already given us, you know, basically this got canceled out. Now, before we can work in the parentheses, we got to do something here. We got to do something. We got to do something at 8. How do we cancel out to the 8th power? Right here. We're going to 8th root this bad boy. And that's going to cancel out this side right here. So now I'm going to go ahead and put 8, and I'm going to hit y root x, which is yellow square root button, okay? Yellow square root button on this 35s. Look, I mean, I'm going to show you right here. If you can't see it, we got the 35s. It's right there. Right there, that's the square root. Right above it is y root x, okay? So we're going to hit yellow, y root x, and now we have ourselves, well, it looks like the same problem. It looks like the same thing, but the answer changed. It changed a little bit for us. This is what we got. So now, what's next? 1 plus r divided by 4. Well, instead of hitting 1 plus, how do we do this? We're going to take away. We're going to subtract. I'm going to put it over here. I'm going to put this little parentheses around this. I'm sorry about this, ladies and gentlemen, but we're going to subtract 1. Once we subtract 1 from here, we're going to be able to cancel out that bad boy. So I'm going to hit 1 minus. 1 minus. Okay, so now I got 1.20 times 10 to the negative second. And what's our last step here? Well, our last step is we're going to get all of this that we just did, and the opposite of dividing by 4. We're going to multiply this side by 4. Notice, I just went through it. This is a hard problem to undo, but we undid it together. 4 multiply, and now we got ourselves our answer. We go ahead and write 4.79 times 10 to the negative second, right? Right? Wrong. Game over. All that. That was a hard problem. Goes down the toilet, down the tubes. If we don't see that we want this as a percent, and how do we change a decimal to a percent? Because this is a decimal answer. The R is decimal. We got to hit 100 multiply. And now we got ourselves a good answer. 4.79%. Dude, this is a hard problem. You got to know some algebra. You got to be able to undo the operations. You got to be able to work through this correctly. But with Mr. D, Mr. 500 here helping you out. Easy as pastelito. Yeah, boy. Oh, man, I could go for some cake right now. Okay, sorry about that. I'm over here thinking about cake. The only cake I should be thinking about is making that cake from interest. Yeah. You like that? You like how I segued it? Yeah. Be here all night, fellas. Ladies and gentlemen. I'm just joking. Messing around. I won't be here all night. I might be here all night. I don't know what I'm going to be doing. But it has nothing to do with this problem because we got $10,000. We got 4 5/8%. This, I don't know off the top. Well, I do. I'm a math guy. I have to know this. Well, I don't have to, but I do know this. It's 4.625. But this is a perfect opportunity that you could go ahead and hit 4.5.8, hit enter. You changed it to a 4.58 and 4.5.8. So it's going to say 4.625. And then we get at that, and you divide it by 100, and now you got your rate for this problem, okay? So that's how we could do it. So it's going to be 0.04625. And we're going to have 5 years compounded annually. Oh, that's cake. That's good. That's good, because now we got our formula P, parentheses, 1 plus R raised to the T power. Calculate the amount that would have to be invested at simple interest at the same time, and same interest, to produce the same earnings. Ooh, so we're going to have to work forwards. Get our accrued amount. Well, we don't want the accrued amount. We only want the interest. So at the end, we're going to have to subtract our principal to figure out our interest, okay? So we get this formula. We're going to subtract the principal, and then that makes our answer for the interest here, for our, compounded right here. That's what we're going to do. But we're going to do that. And then we're going to have to substitute that interest into another formula and work backwards to see how much we would have to start with simple interest. This is going to be an intense little problem. But it's all good. That's what we're here to do. We're here to be the best, and that's what we're going to do. So let's go ahead and check this stuff out. All right. First things first, I got my principal, $10,000. Okay. We're going to have to go ahead and put 1, enter, 0.04625, add it, raise it to the 5th power. Right? I mean, hope you're following along. Look, here's the deal. I didn't substitute it. I mean, I guess I'll go ahead and substitute. I'm going to substitute it for y'all, okay? You know what? Just because I know some of y'all over here want me to see me substitute, you want to see it done. So we're going to go ahead and put 10,000, enter, 1 plus 0.04625. I had to look at it for a second. I was like, wait, did I do it right? And we're going to raise that to the 5th power. Okay, so that's all I'm doing. That's all I'm doing here. Okay, so I raise it to the 5th power, then I hit multiply, boom. We have made, and this one I'm going to write down. I got to write this down because I don't want to do this problem a couple times like I just did a while ago. Well, wait a second. You shouldn't write this one down because I don't want the total amount in the account. I only want the interest. So we got one more step. I'm going to take away that initial principal we started with. Let's go ahead and take away that $10,000. And now I'm going to write this problem down. Hopefully you see like 2.54. Remember, we're talking about money. We don't want scientific notation with money. We got $2,536.53. That's what we got to work with here. All right, so now we're going to use that. We're going to have to work backwards. We're going to use backwards from the simple interest formula. So when I substitute this bad boy, let me use a different color right here. I'm going to go ahead and 2536.53 equals to our initial. Well, wait, we're looking for how much would be invested. Calculate the amount that would have to be invested. We're looking for the P. We know our interest rate is automatically going to be what? 0.04625. Okay? And we know the time is going to be the same. Why? Why do we know that? Well, again, let me bust it out. Same time, same interest. There you go. So let's go ahead and work this backwards. What do we got to do? We're going to hit 2. Well, we're not going to. Well, it should have been in your calculator. To be honest, it's still in my calculator here. So I got 2536.53. I said it was still in my calculator, and guess what I did? I hit delete. Oh my God, what's wrong with me? Good thing I wrote it down, but I had to do that problem all over again, okay? But anyways, the first thing I'm going to undo, let's divide by 5. And now, 0.04625, let's hit divide. And guess how much money we would have had to put in the bank? There you go. I hope you see it. I hope you see that bad boy. Let me write it in pretty pink. Pretty pink! $10,968.78. Look, the more and more we talk about money, I hope you're noticing something. Simple interest is by far the worst method to invest your cash. All right? I'm talking about your cash because I'm going to be honest with you. You start saving young, you could be a millionaire by the time you're 40, 50. Because that money compounds, it adds up, it works for you. All right? So at the end of the day, I mean, you want your money to work for you? You got to start early and have it work for you by putting it in some savings accounts, some good accounts that get you that money, okay? I'm telling you, work hard. Help your parents out, man, because they spend a lot. They invest a lot in you. And you know, invest in yourself so you can make sure you give them back something. You know what I'm saying? All right, we got Sarah and Jim invest the same amount of money, 10 G's, in separate savings accounts for 5 years. Sarah earns 3.15 compounded annually. Jim earns 2.75 interest compounded quarterly. Okay, this one's going to be a little interesting right here because we may see something happen. After 5 years, find the total amount of the account of the better investment. Now, automatically, some people will assume, don't assume, but they will assume that the 3.15% is a better deal. But, you know, we're only raising that one to 5. And I'll show you what I'm talking about. We got our initial formula, P, parentheses, 1 plus R, right? And in this case, well, I'll write both formulas. Raise to the T power, okay? So my annual one is going to be what? $10,000, parentheses, 1 plus my interest rate for the compounded annually is 0.0315. We're going to raise that to the 5th power, okay? So that's going to be our work here. And it looks bigger. It looks bigger. It does indeed. But we can't assume that it's going to work. Because remember here. This formula, the one that's compounded with something other than yearly, is a little different. It's parentheses. I mean, it's a principal times, you know, in parentheses, 1 plus R divided by N, divided by the number of times in a year we're going to compound it, raised to the N times T power. Now, we're only raising this one over here. We're only raising the one on the left to the 5th power. And that's why it seems like it's going to be bigger. It's going to be bigger. But I'm going to use a different color here just so we could see the difference. Here we still have that $10,000. But we're going to have 1 plus. Now, here's the bad part. We're going to get that 2.75% or 0.0275. And we're going to have to divide it by 4 because of the quarterly. Okay? We're going to divide it by 4 because of the quarterly. But here's the deal. You're also going to raise it to the 20th power. So this may look interesting right now. And we may see something. That's why it's always good to shop the market. You never know which account at the end of the day will give you a better deal. So let's go ahead and take a look at this. $10,000. We're going to go. I'm doing the compound annually one first. 1, enter. 0.0315 plus 5th power. Multiply. I'm going to write this bad boy down. We got ourselves 11677.40 cents. Not bad. We made some money. $1,677 in interest was made. Good job. Let's take a look at the other one. I'm going to use red for this bad boy because, you know, I wrote in red. Okay, so we got 10,000. We're going to go ahead and hit 1, enter, 0.0275, enter, 4, divide, plus. And now we're raising that bad boy to the 20th power. And now we're going to hit multiply here. Well, in this case, it looks like Jim got hustled. I mean, he thought we were compounding more. We're raising it to 20 power, but he didn't end up with more. It seems like Sarah just wrecked this guy. Because this guy only made $11,000. He only has $11,468.62. Remember, we round up. We got to round correctly. So who had the better account? Looks like Sarah did. 11,677.40. I'm not writing the interest amount. I'm writing the total amount because that's what it says. Now, here's the deal. Some of you might have been able to figure it out before even multiplying, before even realizing anything. If you wanted to be able to do something like that, what you could have done is found out our answer for this, or this part right here. Why just that part? Well, because we're multiplying it by the same amount, 10,000, okay? Same 10,000. So you find out what number this is. And then you compare it for this answer. You figure out what number this is going to give us right here. What number this is going to give us. And then since you're multiplying it by the same 10,000, I mean, then you could see, well, which number is greater. That immediately tells you which account is going to be better. So this is maybe life lesson for the future, okay, ladies and gentlemen, for the future. Because I'm telling you right now, these problems, they really help plan your financial future, okay? I'm a big fan of this stuff. Now, look, they're not always going to be that hard and intense. Now we're going to get some baby questions on the way so you guys can practice. Hopefully you get to practice before I do the problem. Hopefully you get to do this problem first, and then you get to see what's up, okay? Anyways, we got simple interest, $5,000, 6.75% 4 years. Let's figure it out. We just only want to know the interest. So 5,000 times 0.0675 times 4. That's it. I equals PRT. Remember these easy problems here. Remember, because these, they're all over the place. We just made 1350. We call it, right? You better put that 00. If you don't put that 00, you just got it wrong. I'm telling you, dollar sign, dollar symbol, dollars and cents. Put them all the time. Get them right. Let's get it popping. All right, 59. We got ourselves, what, Diane. She's depositing some cashola, 12 G's. Left there 3 years, 3 1/8% simple interest. Calculate the amount interest earned in those 3 years, all right? So we're going to have to subtract the principal. Oh, no. This is a simple interest problem again. I equals P-R-T equal P-R-T. Okay, sorry about that. I'm a little excited here. So we're just going to get 12,000. Enter it. 0.03125. Look, I'm a math guy. I know these fractions. But if you don't, you hit 3.1, 0.8, enter, 100, divide, change it to that decimal. And then we multiply by 3, and we got ourselves our answer. Oh, this is beautiful. Great opportunity to show that interest matters. It really does. This person deposited a lot more in the bank, almost more than double. But their interest rate's a little less than half than our previous example. So, I mean, at the end of the day, interest makes a huge deal. Of course, it's not the same amount of time, but it's very close, man. And Travis made more, really. Now, of course, he might not have made more completely. Actually, I think he would have made more. Wow. Nah, maybe not. But the point is that you gotta always check these things. You gotta check these things, okay? You gotta do math. You can't always assume that bankers are doing what's best for you. Do the math. Do the math, okay? Because sometimes people, they don't know the math, and they get themselves into a 30-year mortgage. They don't know what they're doing. Oh, man. Variable interest rates. Oofale. And, you know, whole stock market crashes because of some people. You know what I'm saying? We could go back to year 2000s and stuff. You go look at that housing market crisis, man. You see what really caused that, okay? Anyways, that's some lessons for another time. All right, we got DD deposit $250. Notice how they try to hide it as words. They do that because they want to see if you could read. 5.25%, 5.25% for 5 years compounded annually. Compounded formula. We only want the interest. We're going to subtract the principal. Let's set it up. A equals P parentheses 1 plus R raised to the T power. It's only compounded annually, so why make this difficult? But remember, at the end, we're going to subtract the principal because we want only the interest. All right, so I'm going to go ahead and put $250, multiply it by 1 plus my interest rate here is going to be 0.0525. And we're going to raise that bad boy to the 5th power. And that's it. And that's that. Remember, subtract that principal at the end. So we got 2501 enter 0.0525 plus 5. Why did he exit? Raising it to the 5th power. We hit multiply. And then we got to take away that initial principal to see how much interest we earn. All right. Yellow show. We just earned $72.89. And we call it right there. There you go. Easy work. Easy work and easy money. Make that money work for you. I'm telling you right now, simple and compound interest, my favorite right here because, I mean, really, you could do whatever you want as long as you save early, man. You could be working hourly and you could be a millionaire. I mean, you'd be surprised. Some of these stories I've heard about some people who've been investing young, you would have never thought some of these people would have that big chunk of change, but man, you invest young, it could happen for you guys. I'm telling you, man. I'm telling you. I'm a big fan. I'm a big fan of using that money. I'm a big fan of using that money, but using it wisely, okay? Now, of course, you know, I also, if you know me, I'm a collector. I collect things and stuff, so maybe, you know, it is what it is. But you know what? Use the money wisely, okay? All right, so we got ourselves a compounded annually problem, so we set up the formula already. A equals P, parentheses, 1 plus R to the T power. We got 3.5%. 3.5% or 0.035. That's already 0.035. Okay? For 5 years compounded annually, calculate the total amount. That's easy. We know subtracting at the end. Let's set it up. A equals 25001 plus 0.035. Raise it. Raise it. Raise it. I'm just having a little fun, ladies and gentlemen. To the 5th power. All right, let's set it up. We got 2,500, 2,500, 1 enter, 0.035 added, 5th power, multiply, dollar symbol, yellow show, get that money, $2,969.22. Yeah, boy. Look, I hope you're seeing this, man. People are putting this money away. They're saving it. And this money is just accumulating. It's getting bigger and bigger. I'm telling you, man. Do it. Do it smart, all right? Calculate the amount of interest earned on, okay, it's compound annually. I'm sorry, I skipped it already. Compound annually on $10,000. Now, remember, we only want the interest earned, so we're going to have to subtract the principal. So, A equals P parentheses 1 plus R raised to the T power. And then we get this formula and subtract the principal to give us the interest, okay? Give us, you know what, let me write this a little different over here because, you know, I want you to be able to see that I right there. Bam. So, that's how we do it right there, okay? Let's go ahead and set this bad boy up. Okay, so we got $10,000. Multiply that by 1 plus 0.055 raised to the 10th power, and then at the end we take away our $10,000 we initially started with to get the interest earned on the account. All right, so let's do it. Okay, one. Look, I'm gonna tell you right now. Some of you might not be doing what I'm doing. Some of you might have noticed, Mr. Delgado, Mr. 500, you kind of spend the time by doing the plus sign. Why won't you just in your head put 1.055? And you know what? I got one word for you. I completely forgot to do it the whole entire thing. That's why. Yeah, it's not really one word, one little phrase. So if you were able to figure that out before me, I mean, geez Louise. Yeah, you could have just write 1.055. But, you know, sometimes you get in, we're creatures of habit. You know, I'm a creature of habit. Sometimes I start doing something and I just keep doing it. And, you know, nothing wrong with that. As long as you keep getting your answers correct and you keep working hard and you keep being the best that you could be. And that's something I want to impart on my students and everybody watching this and, you know, just for the future. Be the best you could be, work hard, and make it happen. All right, let's see number 59. Lisa. She got a, look at that interest, girl. Dude, what is wrong with you? Why are you even borrowing money? She's got to pay $125 in interest. Oof. Now, look, here's the deal. Since it's only 1 year, I hope you kind of realize this. If it's only 1 year and it's compounded annually, it actually gives you the same amount of simple interest. Now, if you're compounding semi-annually or quarterly, then it's going to be different. But if you're compounded annually, you're raising it to the first power, which really is just going to be the same as simple interest. So they didn't tell us simple interest. They didn't tell us, but that's what it's going to be. So we got to figure out how much she borrowed from the bank, because they gave us I equals PRT. That's what we got to use. They gave us the interest, $125 in interest. My principal is unknown. I know my rate, 0.0699, and my time is 1, so I could put the 1 here to multiply it, but then we get the same answer here. So really, if I want to figure out the principal here, I'm going to get $125 and divide it by 0.0699. That's what we do. So 1, 2, 5, enter, 0.0699, divide. Hit that. Man, this answers me. What are you doing, Lisa? Come on, Lisa. What are you doing, Lisa? You're borrowing. Oh my God, you're borrowing $1,788.27. Oh man, Lisa, don't be borrowing money to keep up with the Joneses, all right? Don't do it, Lisa. Man, it hurts me, man. It hurts me. Now, anyways, you might not understand what that means, but maybe later on in life, you'll see it. I'm not a big fan of borrowing money. Unless, you know, emergencies happen and stuff. You know, stuff happens where you got to borrow money. You know, you got to, but not always. Not always. If you're just trying to keep up with the Joneses, if you're just trying to keep up with somebody, don't do it. Don't do it. I mean, that's just what it is for me. You know, that's what it is for me. Okay, anyways, let's see. We want to make the same interest at $5,000. Okay? So we already got, but we gotta hit this 3%. So let's see. We're gonna have to work forwards through an interest rate problem, the simple interest, and then we're gonna have to work backwards, double part. That's why it's a problem 60 right here. Notice I haven't gotten into it. Oh man, I didn't even put the correct answer over here. Man, Lisa, you're over here messing me up. It's 27. Look, I would have gotten this wrong. I'm glad I looked at my calculator. We got that wrong. You gotta put the cents. Even if it was no cents, put 00. But it was 27 cents. I mean, really, it was 26 cents and 0.8 of a cent. But we rounded 27. Okay, I apologize, man. But Lisa, you threw me off, Lisa. Don't do it. Don't ever borrow money just to keep up with the Joneses. Okay. Any case, we're gonna have to work forwards. We're going to have to figure out our principal of $5,000 multiplied by 0.0725. Now, look, I could put the 1 there, but, I mean, we don't need to put the 1. And that's going to give us our answer in interest, okay? Let's go ahead and do it, okay? We got $5,000, 0.0725, hit multiply. Okay, so what I've seen right now, and I'm going to hit yellow show, this is about, in my interest, should be about $362.50. That's how much money was earned. Okay? In interest. That's how much money is interest earned in that 1 year. Not bad. 1 year. Get yourself a nice little $362. I mean, get yourself a nice little Xbox One. You know, get that Xbox One. Well, you know, I'm not going to be doing product placement here for things, but, you know, Yeah, I mean, you pretty much get a game system with something like that. Just putting money in the bank, get a game system. No, but that's a good interest rate. See, that's the kind of interest rates I'm talking about. You get some of that. You don't want no 3%. 3%'s a little... I mean, I borrowed at 3%. I bought my house and I borrowed at 3.25%. So there's something. There's something. You don't want to be borrowing at these high percentage, but you want to be investing at those higher percentages because they're going to give you more money. Okay? Now we're going to have to work backwards here. We already know the interest. We do not know the principal, and we're looking for it. So we're going to go ahead and substitute. Again, we don't have to put the t because the t in this problem is going to be 1 because, you know, that's just what it is. So we're going to go ahead and 362.50. We're going to go ahead and still put p, but we know our interest rate now is going to be 0.03. Do I have to put times 1? No, I don't, because it's going to be the identity property of multiplication. It's going to end up being the same number. Same number. So we don't need to be putting that. So let's go ahead and do it. Let's go ahead and do it. Well, wait. We got to cancel. We can't just do it yet. We got to do the algebra. What we got to do is divide this side by 0.03. And whatever you do to the right, do to the left. But notice, you just cancel them out. They go away. And that's how we get our P right here. So 362.50. Then 0.03 divide. And that's what I'm talking about, man. I'm not a fan of these low interest rates. To be able to buy that basic game system that we bought in that other account with $5,000 in there, which is kind of reasonable. Dude, I gotta have $12,083.33. Don't do it. Don't get these bad interest rates. I'm telling you, even the stock market averages 12%. It averages. That's how much we get in a year. You know, some of these, I mean, if you actually know what you're doing, I mean, there's some investment funds. There's some, look, I'm not going to talk about investment funds and stuff, but I'm going to tell you, get yourself a good interest rate. Okay, let's check this one out. We got Tim, invested. That's what I like to hear. You invest. Invest that money. You don't need to be buying stuff. $7,500, 3% for 1 year. Calculate the interest rate needed to earn the same interest on $5,000. So again, we're going to work forwards, then we're going to work backwards. So right now, we got to figure out this interest. I equals P times R. Look, I'm already dropping the T. We don't need the T because the T is 1 in this problem. So we're going to do 7,500 multiplied by 0.03. 0.03. Let's see it. Let's see it. So 7,500, 0.03 multiply. My interest for this problem, we just solved it working forward, $225. Boom. Okay? We're going to use that right now because now we're going to have to work backwards. We're going to use that same formula, the I equals PR. Notice, again, I dropped the T. The T should be there, but when we multiply by 1, it's going to be the same thing. PR times 1, because my T is 1, it's going to be the same thing. So I'm going to substitute 225 equals to my P, which I'm looking for the principal, how much this guy has to invest to earn the same interest on, what, 5,000. Oh, wait. I know. Oh, wow. I didn't read this correctly. I actually know the principal. The principal is 5,000 in this problem. We're looking for the interest rate. It even says calculate the interest rate. It's got even that percent symbol, man. I'm glad I saw that because they didn't have a dollar sign. So that means we're looking for the rate. So we got this 225. We got to eliminate. We got to cancel out these things over here. So we're going to divide both sides by what? Can you see it? 5,000. Guess what happens to the 5,000s, ladies and gentlemen? Cancel them out. You know what I'm saying? Cancel them out. So we got 225, 5,000, divide. We write 4.50 times 10 to the negative second, right? We write it. Don't do it. Don't do it. Don't do it. It's a percent symbol. So that means we got to turn it into a percent. We're going to have to hit 100 multiply because we want that percent, and we would have to have 4.50%. Or if you want to write in scientific notation, 4.50 times 10 to the 0. I hope we have that 0 power as an exponent. You realize you don't need to write the scientific notation. But there you go, ladies and gentlemen. Okay, next problem right here. We got ourselves, what? $10,000 invested, 3.125 compounded annually. That's good. 5 years. Compounded annually. Okay, amount of interest earned. So we could actually, I'm going to write the other formula. I'm going to write the I formula. The I formula. The interest earned formula for compounded yearly. Okay, so it's going to be the same thing. P parentheses 1 plus R raised to the T power. But then at the end, we subtract that P. That's what we do. We subtract that P. Subtract that P. Sorry, I'm messing around over here. You know, look, honestly, we could actually factor out the piece from both of those terms. But you know what? We're getting too far into it. We don't need to do all that stuff. All right, so let's go ahead and do this, okay? We got ourselves what? You know what? Like, I'm going to do this real quick just in case you want to know what I'm talking about. Look, we can factor out that P. We could go ahead and do I equals, because, you know, I mentioned it, might as well do it. We could factor out that P from both of these and actually put 1 plus R, raise it to the T power, take away the 1, and then multiply it by P at the end to figure out our interest. But see, that's already a lot. Like, we don't need to do all that stuff. If you're able to do it, that's great, but you don't need to do it, okay? You don't need to do this. This is the formula right there. You don't need to do all that other stuff. This involves high-level algebra knowledge. But if you could do that, power to you. Power to you. My hat's off to you, because I will be the first one to tell you, like, you are better than me. That's for sure. Because I'm a math teacher for a long time, and now I could do this. But if you were able to see this before, dude, I mean, I had to become a math teacher to be able to do this kind of stuff. Anyways, let's go ahead and get this pop. Let's get it popping. All right. Okay. Oh, man, just having a good time. I'm telling you, man, we having a good time. When we solve math, we have a good time here, okay? So we got that P. 1 plus my interest rate here is 0.03125. We're going to raise it to the 5th power. And at the end, we're going to subtract 10,000. That's going to give us our interest earned. So let's get it popping, okay? So 10,000, we start with that. 1.03125. If you want, you don't have to hit that plus sign. Raise it to the 5th power. Hit multiply. 10,000. Take away that. And we got that money. I got about $1,663.26. Look, it was going to be 25. But that 5 makes it round up. Don't believe me? Let me show you right here. I still have that yellow show right there. That 5 makes it round up. I wanted to say 25. But I can't. Gotta put that 26. But you could put 25. You could be 1 penny off. It's all right. Let's do it. Let's next problem. We got this guy Travis. Deposited $8,000. 3.85% interest compounded annually. That's what I like to hear. Easy problem. How much money will be in the account at the end of 6 years? All right, let's do it. How much will be in the account? We don't need that interest. We're just going to do that regular accrued amount formula. A equals P parentheses 1 plus R. Raise it to the T power. Let's do it. $8,000. 1 plus 0.0385. Raise that to the 6th power, because we got 6 years. And that's it. 1.085. Enter. 6. Y to the X. 8,000. Multiply. And we got ourselves a beautiful answer here. 10,000. 35. Ooh, you know what? That looks a little sloppy here. Honestly, that looks a little sloppy for me. That looks like a 6. I'm getting a little sloppy, ladies and gentlemen. Don't get sloppy here, okay? Because you get sloppy, you might end up getting something wrong, and you don't deserve to get it wrong. So let me go ahead and write it correctly. The correct answer here, I'm going to go ahead and write it over here. 10035 and 27 cents, okay? Look, I know I go kind of fast, and I know in calculators we want to go fast. That's the whole point here. We want to go fast. But we don't want to get too fast that we get stuff wrong, okay? So that's what I kind of am a big proponent of doing it right. We got to do it right, because you do it right, you're going to be right, and we're going to have no problems getting those 9 points, those 18 points. With those good scores, make sure we can show them that we the best. Whoever works hard, we always the best. That's what I'm about. All right, so let's see what we got here. We got ourselves $7,500, 7.25% annual interest. Compounded semi-annually. How much will be in the account after 7 years? We got ourselves that fancy formula, that fancy multiple compounded formula. A equals P parentheses 1 plus R over N to the N times T power, okay? I was going to put the dot, but, you know, variables touching means multiply. Let's substitute correctly. We got 7,500 times 1 plus 0.0725 divided by, since it's semi-annually, we're going to divide it by 2. And now we're going to raise it to the 2 times 7 power. Or if you want, you could just think of it as the 14. But I'm writing this because I bet you somebody might say, where did the 14 come from? Where did the 14 come from? Where did the 14 come from? Well, I'm telling you, it came from 2 times 7. Let's get it. 1. Well, I'm going to start with my parentheses. 0.0725, enter, 2 divide, add it. Okay, whoa, I think I did something really wrong here, okay? That's why you got to make sure that you're doing this stuff right. So now we're going to raise it to the 14th power. I got 1.65. And then I'm going to get that and multiply it with the 7,500 I originally typed. We don't care about the interest. We want what's in the total account right now. And see, that wasn't that bad. I mean, we almost doubled that 7,500. 7,500, 7 years. It grew to $12,347.10. Notice you could have put 9 cents, but it's 9 cents with 7/10 of a cent. So I go ahead and round that to 10. Okay. Let's take a look. Next problem here. Let's do the next problem. We got ourselves Sandra. Sandra deposits $5,000, 3 7/8% compounded semi-annually. She keeps the money in the account for 5 years. Calculate total balance. Total balance. Another word for accrued amount, or the A. It's the same thing in those 5 years. So we got the accrued amount equals principal 1 plus our rate, since it's semi-annually again. You see that bad boy, right? You see it. It's going to be divided by what? Well, it's divided by n. When we substitute, it's going to be divided by 2. And we raise it to the n times t power. All right, let's go ahead and substitute. We got ourselves 5,000. Again, this is a perfect opportunity to do 3.7.8, enter, 100, divide, and get your rate. But if you know your math, if you're a number sense, or you just got that math knowledge, you can go ahead and understand what's going to be there. Because really, this is going to be what? I hope you said it. 0.038. There you go. Keep going. 75. Sorry about those eyes. Sometimes I see it. I get that excitement getting over me. And then I go divide by 2. And now we're going to raise it to the 2 times 5 power. Or even better yet, let's raise it to the 10th power. All right, so let's go ahead and see what we get here. We get 5,000. Enter. 1. Enter. 0.03875. Enter. 2 divide. Add it to the 1. 10. Raise it to the 10th power. And then multiply it by original $5,000 in principal. And we got money problem. 6, 0, 5, 7. And 73 cents. All right. Easy work, man. More and more we practice, the easier this becomes. All right, let's do another one here. Let's get it going. Let's get it going. We bought a new pickup truck for $51,568. Wow. He put $10,000 down. Wait a second. That's not. Dude, he must have borrowed a lot of money for this pickup truck. And he received 5. Dude, he traded in a vehicle? I don't like this. This is a bad move. Bad move, man. And he's financing the rest? Oh my God, he's borrowing a lot of money just so we could have that pickup truck. I don't know. I'm not a fan of this. I'm not a fan of this at all. But this is my personal opinion. Now this one's an interesting problem here. I bet you this is from a state test or a regional qualifier, because we don't want the total amount owed. We want his monthly payment. So when we figure out this whole entire problem, when we figure out his total amount owed to the bank, because he borrowed money, we're going to figure out how much he has to pay per month just to borrow this money. So first things first, we're still going to use that A equals. Okay? Now it looks like, I mean, we could probably do a simple interest. It doesn't tell us it's compounded. So our accrued amount, our total amount that we're going to owe is going to be, what? P. And then it's going to be RT plus 1. Right? Or if you want to think of it this way, we could do our interest, simple interest, PRT problem. And then once you get that, you could add the principal again to go ahead and get the total accumulation. Okay? The accrued amount. Okay? It doesn't say we're compounding or anything. But you got to be careful too, because honestly, sometimes when you're borrowing money, they don't give you that simple interest. They're compounding on you. And that's why it's kind of intense. Let's figure out how much money he borrowed. The principal. All right. So we're going to get the principal by go ahead and getting that 5, 1, 5, 6, 8 takeaway. $10,000 because he already had to pay that. Then we're going to have to subtract another $5,000 that he had to. See, this is what I'm talking about. How are you going to pay over 50 grand for a truck or a pickup truck? And when he traded in that other vehicle, they only gave him $5,000. Dude, that's like 1/10 of this pickup truck. And I almost guarantee that if he bought that pickup truck, this old vehicle that he traded in, he probably did spend around that amount of money. I mean, this is a lot of money to go down the drain just so he could buy a truck that's, you know, brand new or whatever. But of course, there's other things that happen. I mean, this guy might have been using this other vehicle for a very long time, might have a ton of miles, and that depreciates the value of the vehicle. But that's why you gotta know math. Because sometimes we just start buying things and we don't really realize that we don't need the stuff we're buying. We might as well be better off putting that $10,000 into a bank account, get some interest on it, maybe double it in a couple years, and you know, we keep working from there. Add a little bit of money every year, and you know, see that money just pile that money up. But I don't know, that's me. So we do that. Anyways, I'm going off track. We do that, we figure out how much our principal is. So 5, 1, 5, 6, 8, enter. 10,000, subtract. 5,000, subtract. And I see that this guy's principal in this problem is now gonna be what? 36,568. All right, that's cool. That's his principal, okay? Now we got to figure out the total amount he's gonna end up owing from borrowing this money. So let's go ahead and figure that thing out. We're gonna go ahead and get PRT and then add the P at the end, or you could do that initial derived formula. Doesn't matter, but we gotta do that simple interest. Okay, so we're gonna get that amount 36568, multiply it by 0.0325, multiply that by 3 years, and again at the end add the principal again, because I equals PRT only gives you the, you know, the interest. So the total this guy owes for borrowing this money, here's my A. This is what I figured out. Hopefully you got this too. In either formula, it doesn't matter. Either formula works, but my A in this problem is now $40,133.38. So most of the time we would be done here, but the problem is that we don't care about the total. Man, that's still a lot of money, man. Just borrowing, man, it's a lot of money. But in any case, we want to calculate his monthly payment. So how many months is in this 3 years? You got 3 years he borrowed the money for, 12 months per year. So we got a monthly payment for a total of 36 months. That's our total months. So guess what we got to do with this total amount? We got to divide it by 36. Find that unit rate. Find out the cost per 1 month. So 36 divided. Oh my God, dude, this hurts to me, dude. $1,114.82 is what this guy is paying per month just to have this pickup truck. Oh my God, dude, this guy. I mean, that's $12,000 a year. 12,000. That's crazy, ladies and gentlemen. That's crazy. I don't know, but that's just me. Okay, I don't know. Some people like doing that kind of stuff, but I'm about making that money work for you, and hopefully, when you know math, you're gonna be able to see how's that money gonna work for me. You know. Anyways, let's go to the next problem. Let's see what Taylor's doing. $4,000. Account 4.5% compounded annually. Calculate the number of years it would take to have at least 10,000 in the account. Okay, all right. This isn't that bad. Now, here the deal is that we gotta actually see what's gonna be our number of years here. Okay, and this one's kind of interesting. Maybe we might have to do a guess and check type thing. So we got 4,000 here. Okay, we got 4,000. Now, but let me write the formula. Since it's compounded annually, we got A equals the total amount, because we want 10,000. Okay, at least 10,000. A equals, and we're gonna go ahead and do P. Here's our principal. 1 plus R, and we're gonna raise it to the T power. Okay. Now the problem here is it's gonna be very hard to inverse this. I mean, there is ways to do it. Don't get me wrong. We could do this easily. I mean, if we use logarithms and things, we could figure this out. But I'm not going to do a logarithm lesson right here doing simple compound interest. No, we're not going to be doing that. What we can do, though, is we could figure out what the number has to be when we do 10,000 divided by 4,000. Look, this is what I mean. We could figure out what T is with a simple guess and check. And, well, there is something we can do to simplify this. We could basically get our total amount, the total accrued amount, which is going to be $10,000. That's our A. We could already just divide it by 4,000 because that's what we're going to do if we were working backwards. And that is going to equal to 1 plus, and then we're going to go ahead and see my rate here in this problem is 0.045, and we're going to have that raised to the t power. Again, this can easily be done with logarithms. But again, this is not the time that I'm going to throw logarithms. Logarithms another time. I'll do it for the overflow problems, and I'll show you how they really work. But right now, I'm not going to be doing logarithms. So what I'm going to do, and hopefully what you can do, is we're going to get 10,000, and we're going to go ahead and divide it by 4,000 to see what does our 1 plus 0.45 raised to the t power have to be. We're trying to see 2.5. That's what I got. Let me write it a little cleaner. We got, and let me write it difficult. Let me do that pretty pink. We got 2.5 here. That's going to equal to 1 point. Well, I'll put 0.045 because I'm already combining it. Raised to the t power. So what we could do now is start substituting and get the first value of t that gives us something bigger than 2.5. So I'm going to go ahead and put 1.045. First t I'm going to try is I'm going to try 15. I like 15. I don't know, I just like it. Let me raise it to the 15th power. I raised it to the 15th power. When t equals 15, my answer was 1.94. I need to get at least 2.5. So we're going to have to go higher than that. Let me try the 25th power, okay? I think that's probably going to be a little too much, but, you know, we could try it. You know, but at the end of the day, this is a little technique that we could do. Let's raise it to 25th power. See, I got 3.01 there to the 25th, okay? So my t raised to the 25th, the answer I got was 3.01. I don't want 3.01. I want 2.5. So it's going to be somewhere in the middle. Let's go ahead and try 20. When t is 20th, 1.045, 20 y over x, I get 2.41. So when my t is 20, and notice I'm using a little guess and check strategy. I mean, you know, it works. It works. I'm not going to do logarithms right now. I'm not going to do it. I could do it, but I'm not going to do it. So let's try raising it to the 21st years because we're pretty close. 2.41 is super close. So I'm going to get 1.045, and then I'm going to raise it to 21st power. Boom. The first time. It looks like 2.52. We were looking for 2.5. It's an integer problem. We cannot have fractional parts for this. So it looks like t, when t is 21, I got 2.52. So how many years would it take to have at least 10,000? Looks like we're going to have 21 years. Okay, ladies and gentlemen. That was a little interesting problem right there. That's kind of like the think outside the box problem. That's kind of like you got to actually know how to do math problem. But you know what? Me and Mr. Delgado here, me, Miss 500. When I say me, I mean you. Because you're thinking in your brain. Because you're going to work hard for this. You work hard for this, man. We can get this popping. We can get this knocking off the charts, right? Jamie wants to make $500 per year in simple interest. How much would he have to invest? At 3.5%. Easy work. Simple interest. I equals PRT. We already know how much we want to make a year. We want to make 500. We want to make 500. We don't know the principal. How much would we have to invest? He have to invest. I don't know. We're going to figure it out. But we know the rate's going to already be 0.035. Since we want to do it per year, I mean, we know our time. Our time is going to be 1. Do I need to put 1 there? No. Honestly, we already got our work here. You know, I'm going to set it up here. Let's go ahead and just set it up. We got to divide both sides by what? 0.035. Whatever you do to the right, you do to the left. Notice how my right side cancels each other out, and I get 500. And I'm going to divide 0.035 from it. And the minimum, oof, that's why these percentages, when you got a low interest rate, man, you got to make your money work for you and work the right way. I ended up with $14,000, 285 and 71 cents. That's what you gotta have in the bank to make 500. Dude, I don't know. I'm not a big fan of that. I'm telling you. Low interest rates, low returns. Low interest rates, low returns. I don't like it. I don't like it at all. I don't like it at all. Like for example, I keep telling you about the stock market. I might as well just go off on it. What if we were getting about 12% interest? Because the stock market returns. About 12% returns on your money, on your capital invested. Well, I mean, just look at it. We want $500 per year. Well, I'm still going to have the same P that I'm looking for, but if it was 0.12, I mean, come on, dude, come on. Let's see what happens. I mean, we do the same thing. We divide by 12 on both sides. Or 0.12, I apologize. The 12s, guess what happens to the 12s? Cancel. 500 divided by 0.12. You only need $4,166.67. I mean, that's huge, man. That's almost a third less than what you need to make $500 here. Look, the point is, get good returns, work hard for your money, keep saving your money. Always go for the compound. Always go for the compound. That's what I'm talking about. Always go for that compound. I'm talking to you. I'm talking to you. And we get this popping, man. We got this popping over here, okay, ladies and gentlemen? So, look, I had a good time. This was a long little lesson, but as you can see, man, we did a lot of problems. These are hard problems. These wreck people. These are problems from the 20s, maybe 60s, 71s. State-level questions are here. Not only that, but there's just a lot of money problems. I really love this stuff, ladies and gentlemen. I do. I love this stuff because the more and more we work, the more and more we're going to be able to understand our simple and compound interest problems right here, okay? Now, I have no idea why it moved over. Oh, I know why it moved over, because I slid it over. But that's my simple right there, okay? And so, hope you had a good time. I know I had a good time. And hopefully you guys learned a little bit, man. This is the good stuff right here. And I hope you guys have a phenomenal day. And enjoy that turkey day if you're watching this before Thanksgiving. Probably not, because honestly, if I were a kid, I wouldn't even be up on Thanksgiving, even close to this. I'll probably look at this Sunday night, maybe Monday when Mr. Delgado reminds me. I put up all these videos, and you're going to be like, oh crap, I should have been looking at it. Yeah, I know. It's all good.